Bismillahirrahmanirrahim. Assalamualaikum. In this video, I'm going to explain on the final chapter of our course, which is Design of Experiment. The content of this chapter will cover the introduction of the Design of Experiment or DOE, and then introduction on the DOE, which is we are going to learn on the single factor experiment, and then analysis of variance, which is ANOVA. So this is where we will conduct a test to whether there are factors that are significant contribute to the response or the observed data. And then we move to the second test where we compare we call it multiple comparison techniques, which is we compare which factor that contribute to the difference of the which from this one for the first test. Okay, so this is for the overall test, whether they are different between the factors. And then the second one, we will test which factor that gives significant effect, means that in more detail. Okay, so the second test is more detail. And then the last one, we will test on the residual, which is we will conduct the residual analysis and the model adequacy checking, which is from the model residual, we will check whether our model is acceptable or not. Okay, this is the learning objective of this chapter. So it is based on the previous chapter content. So the first learning objective is at the end of the chapter, student will able to design and conduct engineering experiments. So it will involve a DOE, and then explain the concept of completely randomized design. And then thirdly, perform the ANOVA test, which is the analysis of variance from the respected experiment. And then conduct the analysis test for the experiment. And lastly, perform model adequacy checking with the residual plot. So in the first chapter, actually we have go through of the introduction of DOE. So in this chapter, we will look in more detail how to conduct the test of DOE. So for introduction, which is such as a repetition from the chapter 1. So what is DOE? So we recap some of chapter 1 content. In engineering field, so there are a lot of experiments need to be conducted. So how we design the experiment? So we have to use the DOE, design of experiment, means that we are not simply conduct the experiment, but we have to design it in very detailed and well planned. So DOE is actually very important when involving experiment. So why it is important in engineering field? So because it can help to optimize the characteristic of the process, any process that involving the experiment, and then we can evaluate the material properties, and also it is important in the product design and development, and then component and system tolerance determination. So all this one is involving experiment. So from the experiment we have the result. So from the result we can make conclusion. So that is why the design of this experiment is very important. So this is in more detail what is the benefit of DOE. Just now is just the general. So in terms of time, so because we optimize the process, so we can reduce the time in order to develop new product and process, for example. And then we can improve the performance of existing process because we conduct an experiment, so we can know how to improve the performance and also the reliability of the product. And then we can achieve the product and process robustness. And then lastly, we can evaluate the material design alternative, setting components, and system tolerance. So these all the involving process or factors that contribute to the manufacturing process. So we can evaluate them. There are several types of design of experiment. So the first one is one factor design. So the factor can be quantitative or qualitative or quantitative. So for quantitative, we can adjust or we can control the level of the factors. But for the qualitative, we cannot adjust them. Means that no prediction can be performed outside the tested level because we cannot control the level of the factors. Secondly, we have the factorial design, whereby we have multiple factors, which is we want to investigate simultaneously the effect on the response. So the factors can be qualitative or quantitative. So same goes with the first one. But now we have multiple factors. Just now only one factors. So for the purpose of the factorial design, we want to identify the factors that have significant effect on the response. So we have several factors. So we want to test which one give effect on the response of the observed data of the process. And then we also want to investigate the effect of the interaction between the multiple factors. In more detail, the factor design can be divided into three types, which is the two-level full factorial design, two-level factorial fractional factorial design, and lastly, the general full factor design. So the first one is only involving just two factors. So it is restricted only for two factors. Second one, we assume that we can neglect the high order interaction between the factors. And then lastly, general full factorial design, whereby each factors can have a different number of level. So afterwards, we will learn in more detail what is factors, what is level, and what are the quantitative and qualitative factors. So this is some of other example of DOE types, but it is not included in your syllabus. So it is just an introduction for you. So means that you know that there are several types of DOE. Let's look at this first example. So you have to know what is factors. Okay, so factors is the input to the process and can be classified either controllable or uncontrollable. So how we know that it is controllable or uncontrollable? So basically, in general, we can say that it is the factor is controllable if we can control the level. For this example, okay, so let's refer to this example. We have two factors, which is the machine and the feed rate. So now we can control the feed rate, okay, in millimeter per second, which is we have 0.2, 0.4 and 0.6 here. So means that we can control the rate here. So feed rate is the controllable factor. And then another factor is machine, type of machine. So we have two types here, which is USA and Japan. So here we cannot control the level, means that we just have the type of the machine. So means that it is uncontrollable. So this is one of example to differentiate the controllable and uncontrollable factors. And then another terms that you have to know, okay, response. So what is response? So response is the output of the experiments, which is in this example, it refers to the process capability. So it means that in this case, the higher process capability is better. So it means that from this output or the observed data from the experiment, so we can see that the combination, okay, because here is the USA machine, and then when the feed rate is setting at 0.2 mm per second, so this is the observed or the response. So we call it response or the output from the experiments. Means that for each combination here we have two response. So in general, in this result, we can observe which factors contribute to maximize the process capability. So we can observe here that this is the highest, which is by using the machine USA. Okay, and then the feed rate is 0.2. So we can conclude that using USA machine at lowest feed rate, okay, because 0.2 is the lowest feed rate now, and then it can result in maximize the process capability. So here the conclusion just been made by observe the result, because it is such obvious that it is the maximum compared with other response. So we can conclude simply from the result, not conducting any tests. So it is just in general. From the example just now, we can differentiate types of factors, which is we have quantitative and qualitative. So quantitative here, in this case, it is temperature and time, because it is in millimeter per second. So this is the quantitative factors, and they can be controllable, which is we can set the level of the feed rate. And then for the machine here, it is qualitative. So means that we only have the type of the machine, and then we cannot control the level. Okay, so quantitative and qualitative. So quantitative just now, it is temperature and time, and then we can set the value. And then qualitative is the machine operator. So there are different categories. And other example also, we can say that for switch, okay, so whether it is on off, so that is also qualitative factor. And then we have the level. So for temperature, we have several levels that we can set. For example, here we have 10, 20, 30, 40. So we have 4 levels of temperature. So the temperature is the factor. So here is the level of the factor. So 4 different levels. And then we have 2 types of machine, which is USA and UK, and also Japan. So here is a different example. So we have 3 level of machine, which is according to different type, but we also can call it level. So level of machine, but according to different type. And then for the switch just now, we have on off. So we have only 2 levels for factors machine. Sorry, the factor is switch, whether it is switch on or switch off. So the level is only 2. So I hope you already understand what is factor. Okay, what is factor, what is response, and types of factor, and also the level of the factors. So in DOE, there are several terms that you need to understand and remember, so that afterwards when we look at the calculation, when we do the calculation, you can understand well, because it will involving formula involving the terms in DOE. Okay, let's look at other terms. Okay, run. So what is run? Okay, a run is one set of levels for all factors in experiment. So let's look at this example. Okay, in this example, we have 3 factors, which is the first one is temperature, second is machine, the type of machine. So, and then we have the third factor, which is the switch. So there are 24 runs, so 1 to 12, 13 to 24. Okay, so it should be split here into 2 tables, because it continues here, 1 to 24. 3 types of factors. And then when we look at the temperature, there are 10, 20, 30 and 40. So means that there are 4 different levels of the first factor, which is the temperature. And then for machine, we have Japan, USA, UK. Means that we have 3 levels of the second factor. And then last factor, switch, we have on, off only. So there are 2 levels of the last factor. So by referring to the factors and their level, different levels, so we can conclude that how many run we have. So how to calculate the run? So in this example, we have 3 different factors, and we have several level for each factor. So for the first factor just now, we have 4 level. The second factor, we have 3. And then the last factor, we have 2. So means that in order to find the rank, we multiply the level of each factor. So we can get here for that the second example table just now, it is 24. So we have 24 different rank. So that is why when we look at this table 2, here we have 1 to 12 and then 13 to 24. So means that we have 24 rank. Means that for each rank, if you observe, there are different combination of the level of each factor. So there are no similarity here. Okay, so means that there are 24 different combination of the 3 factors and their level. So they have 24. Okay, so that is what we call rank. So please remember this also. So it is very important. And then next we have the terms of replicates. So what replicates means? It is the number of observation at each rank. So means that how many observation or how many output for each rank. Just now we have 24 rank. So how many we repeat the experiment in order to get the output. So that is what we call replicates. A large value of n increase. So n is replicates. Okay, so n represent the number of replicates. So the larger value of n, so it will increase the accuracy of experiment. Of course, because we have a larger number of observed or sample, we call it. In previous chapter, we call it sample. So of course, if there is larger sample, so it will increase our accuracy of result. But of course, if we do run the experiment in many times, so the cost will be increasing, because experiment, of course, it will involve cost, workmanship cost, and also the time. So we have to consider the cost in order to do the replicate. So we define the replicates number by considering the cost that it will be involved. Okay, next we have the terms of response. Okay, just now I already mentioned what is response. Well, it also means that the output of the observation means that when we collect the data, so the response is the data itself. Okay, so response is the dependent value of the factors. So means that it depends on the effect of the factors. We control the factors and then we observe or we record the response. So means that the response is the dependent value. So in order to make a conclusion, we can know the response. Means that we have to know how we can conclude based on the result, whether the response, the larger the response is the better or smaller or nominal. Okay, so there are several types of response according to our objective of the process, whether we want to maximize, minimize, or optimize. So we can say larger, smaller, or nominal. So for example, for larger, for product yields, or of course we want to increase or maximize the product yield, so the larger the better. And then for a smaller the better, so cost, time consuming, so means that the minimize is the better. And then for nominal means that is not involving numerical output, means that it is we can conclude based on the nominal variable. So for example, diameter of shaft, so means that we want to optimize the diameter of the shaft. So by DOE, or the conclusion from the design of experiment, we can find out which factor has effect on the response. So which is factors give significant actually effect on the response where this is the output of the experiment, and then we can know the direction of the influence, whether it will increasing the factors will increase the output or decreasing. So we can know by using the DOE. Okay, this is just an introduction. So in the next video, I will continue with an example. We can see the calculation. So I hope that from this video, you already learned the terms of DOE that we are going to be used in the next video. So please get used to or remember all the terms. Okay, bye. Assalamualaikum.